Hello friends, my name is Bhavesh. This is my YouTube channel. I become engineer. Friends, if you have not electrical book but you still trying to study on YouTube, so this is best channel for you and you can easily solve your doubts, and also this is original topic present front of you. Okay, and if you like my video, so please subscribe and like my YouTube channel. I become engineer. Okay, and I mm, and also I will come with improvement for my video. Okay, so let's get start. And uh, this topic is in this video we are discuss about circuit model of DC machine. Okay, so this is figure, and the theory is in a DC machine all parallel paths in the armature are symmetrical and each path has an induced EMF EA and series and resistance RP. Okay, I'm write this. In a DC machine all parallel paths in the armature are symmetrical and each path has an induced EMF induced EMF EA. Okay, induced EMF EA and a resistance RP. Okay, the armature armature according to Thevenin's theorem can be in represent by the circuit model with voltage EA and a resistance RA series resistance RA as depicted in this figure, where RA is equal to RA is equal to RP. Okay, divided by number of parallel paths. A, that is RA is equal to RP upon A. Okay, A, that is Ra is equal to Rp upon A. The brush voltage, drop is constant. The drop voltage is constant and of the order of 1 or 2 volts. Okay, which is either ignored, which which is either ignored or its effect is induced included in included in armature resistance Ra by linearizing it. Okay, so this is our topic, circuit model of DC machine. In DC machine, all parallel paths in the armature are symmetrical and each path has an induced EMF EA and a resistance RP. Okay, the armature, according to Thevenin's theorem, can be represented by the circuit model with voltage EA and a series resistance RA. Okay, as depicted in the figure, in this figure. Okay, where Ra is equal to Rp divided by number of parallel paths. Okay, where Ra is equal to Rp divided by number of parallel paths. A, that is Ra is equal to Rp upon A. The brush voltage drop is constant and of the order of 1 or 2 volts, which is either ignored or its effect is induced in armature resistance Ra by linear linearizing it. Okay, the field has resistance Ri. The field has resistance Raf supplied with field current If, given by If is equal to Vf upon Rf and is showing 90 degree to the brush axis according to the actual arrangement in the machine. Okay, is this figure. Okay, the field has resistance RF supplied with field current IF. Okay, field current IF given by IF is equal to VF upon RF and is showing 90 degree to the brush axis according to the actual arrangement in the machine. Okay, the field provides the flux per pole which induce EMF EA induce EMF EA in the armature when it runs at speed n. Okay, speed n. The power the power convert the power converted is EAIA. Okay, and power converted mechanical to electrical or vice versa. Okay, I am write this, the power converted mechanical to electrical or vice versa. Okay, EAIA. From the circuit point of view, it is not necessary to rigidly follow this scheme. Follow these since most the steady state DC behavior of the machine will be of the machine will be considered the inductance of the field and armature circuit have any effects and are therefore not shown in the circuit model. The induced EMF in the armature and torque developed are governed by equation, okay, by generating uh, equation, okay. So generating mode first. Mode. So generating mode, okay. So this is for generating mode, and this is motoring mode, okay. I'm write this E for generating mode, and the second is for motoring mode, okay. This is circuit of DC model. So theory is the machine operate in generating mode, that is it deliver electric power when armature current IA and induced EMF EA are in the same direction as shown in the figure, okay. Electromagnetic power is EA IA watts, and electrical power output is equal to VI watts. Here I'm write this: the machines in generating mode, that is deliver its deliver electric power when armature current IA and induced EMF EA are in the same direction as shown in figure, okay. Electromagnetic power is EA IA watts, and electric power output is equal to VI watts, equal to VI watts, okay. So for armature circuit, for armature circuit terminal voltage V is equal to EA minus IA RA. Okay, and electric power output is electrical power output is means P out, okay, is equal to electromagnetic power EA IA, okay, and minus ohmic losses, okay, ohmic losses including brush contact loss, ohmic losses including brush contact loss, okay. So in this mode operation, develop electromagnetic torque TE. Electromagnetic torque TE is opposite to the direction of rotation of armature. That is, mechanical power is absorbed and a prime mover required to run the machine. Am I right? This is topic. In this mode of operation, develop electromagnetic torque TE is opposite to the direction and the direction of rotation of armature, that is mechanical power is absorbed and a prime mover is required to the run the machine okay, that is provide to the necessary of mechanical power, okay. So in generating mode, the machines in the generating mode, that is delivers electric power when armature current IA and induced EMF EA are in the same direction, shown as a figure, okay. Electromagnetic power is EAIA watts and electric power output is equal to VI watts, okay. For armature circuit, terminal voltage V is equal to EA minus IARA, okay, and electric power output P out is equal to electromagnetic power EAIA minus ohmic losses including brush contact loss, okay, ohmic loss including brush contact loss, okay. In this mode operation, developed electromagnetic torque TE is opposite to the direction of rotation of armature. That is, mechanical power is observed to a prime mover is required to the run of the machine. Okay. Okay. And so shaft power input shaft power input is equal to EA IA plus rotational losses. Okay, the shaft power input is equal to EA IA plus rotational losses. Okay, so the second mode is motoring mode. Motoring mode. Okay, so the machine operate the machine operates in the motoring mode when armature current IA flows in opposition to the generated EMF EA as depicted in the figure. Okay, for the armature circuit terminal voltage V is equal to EA plus IA. EA plus IA RA. I'm write this. The machine operates in motoring mode when armature current IA flows in opposition to the generated EMF EA as depicted in the figure. Okay, in this figure. For B, motoring mode, the armature circuit okay, the terminal voltage V is equal to EA plus IA RA. Okay. Okay, in generating mode the shaft power input is equal to EA IA plus rotational loss, and in generating mode the terminal voltage V is equal to EA plus minus IARA. Okay, the terminal voltage V is equal to EA minus IARA, and in this motoring mode the terminal voltage V is equal to EA plus IARA. Okay, EA plus IARA. And electrical power input P in is equal to electromagnetic power electromagnetic power EAIA, okay, plus ohmic losses including to brush contact loss. Okay, so electric power input P in is equal to electromagnetic power EAIA plus ohmic losses including to the brush contact losses. Okay, so in generating mode the shaft power input is equal to EAIA, sorry, the electric power output is P out is equal to electromagnetic power EAIA minus ohmic losses including to brush contact loss. Okay, ohmic losses including to brush contact losses, the difference is only minus and plus. Okay, so in this mode operation, so in this mode operation develop sorry in this mode operation develop electromagnetic torque Te is in the direction of the rotation, that is mechanical power is outputted and absorbed by mechanical load. I am write this. In this mode of operation developed electromagnetic torque Te is in the direction of rotation, that is mechanical power is outputted and absorbed by mechanical load, and the shaft power output is equal to EAIA minus rotational loss. Okay, the shaft power output is equal to EAIA minus rotational loss. So in this mode operation developed electromagnetic torque Te is in the direction of rotation, that is mechanical power is outputted and absorbed by mechanical load. Okay, so shaft power output is equal to EAIA minus rotational losses. Okay, in this generating mode the shaft power input is equal to EAIA plus rotational losses, and this is shaft power output. Okay, is equal to EAIA minus rotational loss. Okay, and and our topic is complete. in this video. Okay. Okay friends, so in this video we discuss about the circuit model of DC machines. Okay, so we are complete in this topic in this video. Okay, so thank you very much. Have a nice day.